Hello friends, this particular week we have been talking about water quality and treatment, and in earlier lectures we did talk about the basic importance of water quality, what are the different sources of contaminant that can come into the water, and in the previous class we discussed how do we characterize water. So, in terms of which water quality parameters we report the level of pollution or level of substances, unwanted substances present in the water. Now, this particular lecture we will be taking a step forward and we will be discussing the philosophy of water treatment, and what we are going to cover in this is the concept of water treatment, the very basic concept of the water treatment, and then we will be talking about water quality standards and water quality assurance, and we will be discussing the basic design of a water treatment system. So, what are the different treatment processes and systems for the purpose of contaminants removal from water. So, this in fact is an old slide. So, we earlier saw this in a week before. We have so far talked about the collection work. So, how do we collect water from the source, and in the earlier week we discussed the transmission works. So, how we transmit water, but one of the as discussed earlier that these are the like collection, treatment and distribution are the main three pillars of a municipal water supply system. Of course, in between comes the transmission. So, we did talk about collection, how we collect water, and in earlier week we discussed how we transmit water to the treatment facility, and from treatment facility to distribution mains also we discussed, where or storage structure where we can have what we discussed earlier. The middle pillar or the important part is the treatment or purification work, which is essentially the water treatment plant in the water supply systems. So, this particular week, and in fact the probably next couple weeks more, will be focusing on the treatment of water. So, as we know that pollutants create problem, health issues when basically consumer get exposed to these pollutants in water, and this exposure can be in the form of either dermal exposure or ingestion. So, when we drink the contaminated water or eat food prepared from the contaminated water, or when we take bath in the contaminated water, so we get exposed to these contaminants and then they create lot of problems. So, essentially when we say that we need to go for water treatment, so water treatment is removal of these pollutants from water, and we need to remove these pollutants in order to produce safe water for specific uses. The specific uses could be drinking, specific uses could be like other household activities, specific uses could be the for purpose of bathing in, say, in the swimming pool, specific uses could be agricultural uses or horticulture uses. So, we may need to treat water to make it fit for the designated specific use. The municipal water supply systems have focus on supplying water for household uses, and the typical household uses of water should be meeting the drinking water quality criteria, because water is used for drinking in the houses and cooking, which also basically, so we are like ingesting that water either directly or through food or other forms. So, generally the criteria for municipal water supplies is to meet the drinking water standards. So, traditionally we have raw water, and as we have discussed earlier, the raw water available in our sources is probably not good enough to be consumed directly. So, we need to process that, we need to provide certain treatment in order to convert that to drinking water. In centralized systems, typically this water treatment is provided before sending water to the end consumers. Okay. Though many of us have point of use water treatment system, so right before we use water we have our own RO system or say filtration systems to get the pure quality of water or better quality of water for the purpose of drinking and other consumptions. Mostly drinking and cooking, nobody takes bath from RO water, but many houses have RO or other kind of filters installed in their homes, and they drink water only the processed water coming through these units. So, that is another story, but generally in centralized system or municipal water supply, which is intended to supply water to the consumer, treats water before sending water to the consumer. So, water is taken from the source, then treated and then distributed. Okay. Positively, while treating water, we should ensure that water does not get contaminated after treatment. So, the post treatment safety should also be kind of ensured if possible, so that we can eliminate the chances of contamination in the distribution system. And also we should make an arrangement that water is not stored for very long period in the storage structures or overhead reservoirs. So, as we discussed in earlier week also, that there might be quality issues in the storage level as well, and particularly the microbial contamination chances could be there if water is stored for a very long period. So, we must try to not store water for long period after treatment. Okay. So, that is some of the points one should kind of think before fixing a treatment setup. Now, if we see the very basic objective of water treatment, so water for municipal water supply systems is typically obtained from the surface or groundwater sources. Neither surface water nor groundwater is of quality which can be used directly. So, the very basic purpose or very basic objective of the water treatment is to treat that water, to clean that water, to remove the pollutants from that water, so as the water can be used for end uses like drinking, cooking, cleaning or other household uses. Okay. Or if our intended supply is industrial uses, so we can make it fit for industrial or recreational uses. The urban water utilities which aim water supply for households must provide this adequate level of treatment to make the water potable as well as palatable. So, like as we discussed during the discussion on water rights also, so the two important points under right to water is that water should be safe and acceptable. So, safe means safe to drink, chemically safe, free from pollutants or free from the contaminants, and other was the acceptable. Acceptable means aesthetically acceptable for drinking purpose. So, it is like there should not be too much of color, although color might be safe from health perspective, but people do not want to see the colored water coming from their taps. Okay. So, it should not be colored, it should not have any other material, any sense of order or those kind of thing which is aesthetically unacceptable for drinking purpose. So, that is the major goal. Also, the water which is being supplied should meet the water quality standards set by regulatory authorities. So, our regulatory authorities, there are national authorities, there are international regulatory authorities, they set water quality standards, and these standards kind of provide or these standards depict the acceptable range of water quality parameters. So, we discussed several water quality parameters in the previous week. So, for some of those water quality parameters, these standards guide what is the acceptable range of these water quality parameters for the designated use. Now, if we are talking about drinking water, so what is the acceptable range of the water quality parameters for drinking water? What is the acceptable range for some of the water quality parameters for swimming pool, for agricultural uses that way? And these standards might be set by national agencies, which is like in case of India it is Bureau of Indian Standard or BSI, what we call BIS, Bureau of Indian Standards, and then we have for World Health Organization, like international agencies also, Okay. The United Nations have their own set of standards. So, again it is an international agency made of the several member countries. Okay. Then WHO is there. Similarly, EU, European Union has their own standards, okay, for member nations, and there is country specific standards as well. Like in case of India, we, as we said, that we have BIS in India. Similarly, US EPA, United States Environmental Protection Agency for US. So, that kind of standards are set. So, these are like some of the example of these standards. As we were just saying, in India we follow the Indian standards, okay, which is given by the Bureau of Indian Standards. This is the World Health Organization's guidelines for drinking water quality. So, they have their own standards. This is United States EPA standards. So, these are the sources from where one can see the different standards for different purposes. Now, if we see the BIS standards, which is applicable in India, so that is under IS 10500. Now, the BIS standards in India earlier used to have limited parameters, but in the expansion now they have 6 different tables which talks about 6 different kinds of parameters. Okay. So, like the first one is organoleptic and physical parameter. Okay. So, in the form of like color, what is the acceptable limit, what is the permissible limit, and that way. Then order, whether it is agreeable, has to be under agreeable range. pH value 6.5 to 8.5 should is acceptable. So, pH is, like should be in this range. Okay. Taste has to be agreeable. Turbidity maximum 1 NTU, relaxable up to say 5 NTU, okay, in the absence of any other source. Similarly, TDS is 500 and relaxable up to 2000. Okay. So, TDS value is again one of the very important parameters which is considered for drinking water purpose, and you can see that it is a quite high for drinking water, 500 milligram per liter, because we want essential minerals to be present in the drinking water. We do not want very low TDS water, like generally people do not drink the distilled water. Okay. So, that is the problem. If we are consuming water which is ultra pure, we are getting devoid of several important minerals which is essential for our growth. So, for drinking water, we do not want water to be kind of ultra pure, and we do not want to remove all the even the essential minerals from water, and that is why we have a reasonably high limit of TDS 500 milligram per liter, which can even be relaxed up to 2000 milligram per liter if there is no alternate source available. These are the parameters listed in table 2. The table 2, which is for the general parameters considering substances undesirable in excessive amounts. So, here you can see lot of chemicals listed like aluminum, ammonium, then anionic detergents, barium, boron, calcium, copper, fluoride, iron. Okay. So, all these are there, and then what is their acceptable limit? Say fluoride is acceptable up to range of 1 milligram per liter. In absence of any alternate source, it can be relaxed up to 1.5 milligram per liter. Iron 0.3 milligram per liter. Free residual chlorine 0.2 milligram per liter. Maximum can be allowed up to 1 milligram per liter. Similarly, like magnesium, manganese, mineral oils, okay, nitrate, silver, sulphate. So, lot of parameter including zinc. So, various minerals, their acceptable limit and their permissible limit is given. In case of certain contaminants which is like cannot be relaxed, so we have specifically mentioned that there is no relaxation for this. There is no relaxation for barium, there is no relaxation for iron, okay, no relaxation for sulphide, up to 0.05 milligram per liter is the maximum limit. Selenium, no relaxation. Okay. So, that way for some we can relax limits, and for some it is basically fixed, and we do not want to go for the BIS does not allow the municipalities to go for any higher level. Then the third table is for parameters concerning toxic substances. Okay. So, here various toxic metals like cadmium, cyanide, lead, mercury, molybdenum, nickel, pesticides, so various other things, trihalomethanes, so various elements are listed and their acceptable limits. Since these are toxic, so if you see the acceptable limits are quite low for all such cases. So, it is in a milligram like 0.003 milligram per liter, which is equal to just 3 microgram per liter cadmium is allowed. Okay. Lead 0.1, so that means 10 microgram per liter, mercury again 1 microgram per liter or 0.001 milligram per liter, and almost all of this except a little arsenic, because arsenic is allowed up to 10 microgram per liter, and in case of any absence of the sources it is allowable up to 0.05 milligram per liter, which is 50 microgram per liter. That is because it is very difficult to remove, and particularly in the eastern part of the country there is high arsenic level in the groundwater, and it is quite difficult to remove the arsenic. So, little relaxation has been given in the BIS for arsenic, but for all other toxic metals there is almost no relaxation. Okay. The table 4 is for radioactive substances, the parameter which can be radioactive. So, we have alpha emitters and beta emitters. The guidelines is 0.1 becquerel and 1.0 becquerel per liter. So, that is the guidelines, and there is no relaxation for these radioactives elements. So, we have to see that radioactivity does not exceed then this limit. In the table 5 of the BIS drinking water quality standard, it is specifically targeted to pesticide residue limits. Okay. So, pesticide residue limits, again various pesticides are listed, including like Elacor, Atrazine, Aldrin, alpha lindane, beta lindane, chlorpyrifos, endosulfan, ethion. So, there is a lot of pesticide listed and their limits, again the limits are very low. If you see here, the limits is in actually microgram per liter. So, because pesticides are also toxic, so we cannot have them in a high concentration allowed. So, the limit is quite low for these pesticides. Okay. And the BIS also provides the guided test methods for these pesticides. Okay. The last table, which is the 6th one, talks about the bacteriological quality of the drinking water acceptable as per BIS. So, it gives the amount for E. coli or thermotolerant coliform bacteria for treated water entering distribution system, total coliform bacteria, and treated water in the distribution system. So, generally this should not be detectable in any 100 ml sample of the water. Okay. So, that is the criteria for the bacteriological limits. Okay. So, this is like example for drinking water quality criteria. Similarly, we can have designated criteria for other uses. Okay. For example, BIS has a criteria for swimming pool waters. Okay. So, like that is also available, that was given as back as in 1993. So, again this is a BIS criteria, this is quality tolerance for water for swimming pools. Okay. And this is some of the list of the parameters, what should be the pH value, alkalinity, the aluminum, then residual chlorine, oxygen, iron, heavy metal. So, the different tolerance limit for the swimming pool water as per BIS. There are other like international agencies, for example, WHO, World Health Organization, they also have guidelines for the safe recreational environment water, so for swimming pool water. So, similarly for agricultural uses and other uses also there are criteria, there are standards which must be followed. Now, at several places, several countries, these criteria, these standards are enforcing. So, like the water utility has to meet these standards in case of drinking water. So, the water being supplied into the household should be met, but in India it is although there are standards and utilities are supposed to meet standards, but it's not that we can if utility is not meeting, so we can challenge them in court and those things. So that kind of provisions are not here. So then the idea of water treatment is to provide, as we discussed earlier, is to provide safe and acceptable water, chemically safe and acceptable water, and there are water quality standards available for the designated use or designated purpose, and the supplies should ideally meet these standards. But it is not just meeting standard 1, we have to have an assurance over the water quality as well. So like quality of any other product, the quality of water which is being supplied to end consumers must also be assured. So the consumer must be this is actually almost completely lacking with Indian water utilities. Nobody trusts the water being supplied in the homes. So as in the developed countries, you can actually drink tap water directly. You can go and just open the tap, take water and drink it. But here people are skeptical whether this water is of good quality or not, and that is why we have a huge market for the end use water treatment systems or household water treatment units like RO and various carbon filters. So that is because the quality, that is the quality of water which is coming to our taps is not assured, and it can be assured through synchronized and continued program on water quality data collection, analysis, verification as well as reporting. So utilities must from time to time collect the data on the water being supplied, analyze it in a good way, and kind of report it and show it and verify the data, the accuracy of the data as well. So like in many cities we can see that we have air quality index being displayed. We should have water quality display also in the public water channels, public water mains, that okay, this is the quality of water, say real time quality of water which is being supplied, so that people are aware that the water which is being supplied is of good quality and that can be consumed directly. So that kind of trust building is important, and that can only be achieved when utility go for all these steps of synchronized and continued program on the data collection, monitoring, verification as well as reporting, involving all the stakeholders, so that the trust could be built up. For assessing the quality of supplied water, like again intensive monitoring programs are needed, and the idea is to show the consumers that the water which is being supplied to the consumer is perfectly safe. Now in order to make that water perfectly safe, we need the water treatment. Okay. So the appropriate degree of water treatment must be provided, so that the water quality, and must be ensured also. It is not just we set up a system and whether it is working or not working, nobody cares. So we set up a system, we ensure that the system is functioning as desired. Okay. The quality of water being produced after treatment meets the standard, and then we kind of keep on monitoring it, keep on displaying it, so that the people also can be aware that okay, the water is perfectly safe for drinking purpose. So treatment plays a very crucial role here, that this is the step which converts that water to be to a level of usable water, and of course then through monitoring and display modes it can be made in a public domain, so that public can see that yes, the water which is being supplied to us is of good quality or is of usable quality. Now if we talk about the water treatment processes, so because we have been saying that we need to treat water for removal of the contaminants, so how we treat water? So water treatment, the objective is removal of impurities, and there is no one single step or single unit which can remove almost all the impurities. Yes, there are high end systems like RO and other particularly RO kind of units which can almost remove anything, or distillation or that kind of units which can almost remove anything, but they are very energy intensive and should not or are generally not used on raw water directly. Okay. So, then how we go about it, how we go about treatment of water. So, we may have multiple type of contaminants present in the water, like as we may have, say, we discussed certain water quality parameters earlier. So, like we may have suspended solids. So, suspended solids can be removed by settling. We may have colloids which can be removed by the coagulation, flocculation or by settling. We may have microbial impurities, they cannot be settled, so they probably need another unit for disinfection. So, it is basically a usual water treatment system is a combination of several units. So, several units or several unit steps are kind of encompassed, and overall scheme of water treatment which may have multiple units is designed and is used for the purpose of water treatment. Now, these combinations may have two types of units. There are unit operations and unit processes. So, unit operations are basically rely on the kind of physical separation. So, where physical forces are predominant, like in the step of settling. So, you have large particles or particles of specific gravity greater than 1, which means density greater than water. So, they will settle in the water. So, we have to allow them some time, and by their gravity or by their physical mass itself, they will physical weight itself, they will settle down in the water. So, that kind of processes are known as unit operation, where basically the physical forces predominant, whereas the other type which are unit processes are where the chemical or biological reactions predominant. So, if you want to remove, like in the process, if you want to remove something which is in the dissolved state, okay, you want to basically convert it to the precipitate state. So, you might need some chemical reactions or those kind of step, and for that we may need unit processes. So, there is like they are used in tandem together. So, unit operations and unit processes in combination can give you the good degree of treatment. Generally there are different units available for the removal of a specific kind of treatment. Okay. Like we were discussing earlier, that RO can actually remove a wide variety of contaminants. A settling process will remove the sediments. Colloidal things will basically require the coagulation flocculation process, but that does not mean only that will be able to remove. It can be basically some removal can be through adsorbent, some removal can be through the other high end processes. So, there might be kind of there might be more than one options available, and many times it depends on the designer what to choose, looking at the economy and the best reliability of the available options. Okay. So, separate set of unit steps may be chosen for a overall water treatment facility, and that will largely depend on what is the source of water and what is the level of contamination in raw water. Depending on the source of water, we may have different type of unit structures for a water treatment plant. Surface water source, the water treatment structure for a or water, or basically the sequence of the unit operation in a surface water source might be different than that of the groundwater sources. So, some of the common processes for water treatment are screening, then aeration, coagulation, flocculation, sedimentation, filtration, disinfection, and various advanced treatment processes. So, we will be talking about these processes or these steps in more detail. And if you see some common conventional water treatment systems, so generally like screening can be there, though screening is usually done at the intake level. So, at WTP level, water treatment plant level, we often do not see the screening. but then there is like we may go for aeration or pre-chlorination, followed by coagulation, flocculation, followed by sedimentation, filtration, then chlorination, then kind of these kind of steps may be taken. Then for again surface water sources, we may have raw water coming through screening first, then we directly go for coagulant addition in a rapid mix system, and then we after coagulation flocculation we go for settling, then we go for filtration, then we may go for pH correction, we may go for we should go for chlorination before the supply, which is basically not essentially chlorination, but disinfection, could be other forms of disinfection as well, and then the water is supplied. So, if we see couple of typical layouts for conventional water treatment systems for surface water and groundwater. So, for surface water, again the water from the source, it is collected through screens and then it will be pumped. So, we have a rapid mix where coagulant is added, and then we go for flocculation, so that the colloidals present here can be flocked together, and then they remove in the sedimentation process, and then it comes to the filtration, and from there it basically the disinfectant is added, and then it is supplied to the consumer. So, that is conventional system for the surface water sources, whereas groundwater sources we have additional step of aeration. Most of the time we may have aeration here also in the surface water sources also, or we may not have aeration here, that again depending on the level of contamination and the type and like what is the existing air content of the water. But groundwater sources generally aeration is recommended, okay, or again at times even we avoid aeration in the groundwater treatment system as well, and then we may add some chemical oxidant, then contact tank like the flocculation chamber on those things, and then settling system, so that that is settled and then filtered, and again the rest of process remains same, like we add disinfectant and then supply water. So, these are the couple of layouts for treatment facilities sourced from surface water and groundwater systems. Of course, these are not hard and fast, they can be changed, and we will be discussing some of these points. These couple of pictorial views of the water treatment plant, one is in the Pune, another is in the Jordan. So, these are how they look from the onset, the water treatment facilities. So, we will conclude this here, and in the next class we will start discussing about some of the specific treatment steps or treatment units one by one. So, thank you for joining and see you in the next class.